Okay, guys, welcome to 1.3 day 2. I'm going to have the substitute teacher just pause this video right here while you work out this warm-up in your notes somewhere. Doesn't matter where you write it, notes packet, loose leaf, it does not matter. Just work these out while she takes attendance, and then we will replay the video when she's ready. Okay, so before we get started on this, just a little bit of a morning announcement. So as I messaged you on Canvas, I am a close contact quarantine. So I am, as of right now, out until Tuesday. I will be back on Tuesday. So this has kind of thrown a wrench in our plans for the week. I know it sucks, but there's nothing we can do about it. So it's just part of it, part of the world we're living in right now. So originally my plan was we would do this warm-up, we would hand out our quizzes, see how we did. Some of us did really well, some of us did not. That's okay. But we were going to do a retake for students who wanted that retake option, and that would be done by Monday. Well, unfortunately, since I'm not coming back till Tuesday, that's not going to happen. So, Tuesday, I will be back. Tuesday, I'm planning to give that retake. I don't know yet if it's going to be during class or during wind time. Be looking out for an announcement on that, but we will spend Tuesday and probably Thursday, Friday of next week doing that retake option if you want the retake. You don't have to do the retake. It's definitely up to you, but make sure you check your grade. It is in SIS, and if you think you might want that retake option, you might want to think about just studying some more problems that look just like this warm-up, because this warm-up is basically the fraternal twin of that quiz, okay? But we're going to work out these problems. I'm going to tell you about some of the more popular errors that I saw. But we'll go ahead and get going on this. I'll have some more announcements here at the end of the video, so just stay tuned. So, we've got our f of x function here, which is 2x plus 1. We then have g of x, which is a negative x squared plus 3. And then we have h of x, which is half x plus 6. Okay? The first problem is f times g of x. Okay? Not f of g, but f times g. That is a multiplication symbol between that f and g. So what that means is that we need to set it up just like this. 2x plus 1 times negative x squared plus 3. I saw a lot of people that knew that they were being multiplied together, but they didn't put those parentheses up, so then they didn't know that they were supposed to FOIL this out, okay? So we do have to FOIL this out. That is how we solve this one, and a couple of us had some trouble with how to FOIL, and we'll talk about some extra support that I have for those students who are needing that right now. So we'll start off FOILing this. First step is the 2x times negative x squared. 2x times negative x squared is going to be 2 times negative 1, which is negative 2. X times x squared, you just add the exponents. 2x times 3. 1 times negative x squared. And 1 times 3. Okay, this is the right answer. There's nothing here I can combine. However, to make it written the way it's supposed to, I need to put those exponents into descending order, which is going to look like this. Okay, so hopefully you got that one. If not, make sure you understand what you did wrong. Okay, I will hand out those quizzes next week, so you'll be able to see how you did on the quiz compared to what you did on the warm-up today. Okay, then we have g of f of x, not g times f of x. I had a lot of people just repeat that first problem, which is not correct. Okay, so this is g of f of x, which means that if we were going to write this in that better, prettier notation, it would look like this. G parentheses with f of x in the middle, okay? And that tells us we are plugging in that f of x to g. A lot of people did f of g of x. make sure you pay attention to which one comes first, okay? The first one is going to be the one that's on the outside. When you plug this in, f of x is 2x plus 1. That's what's going in for x and g. So it's going to look like this. Negative 2x plus 1 squared plus 3. Okay. Some of us made it this far. Some of us did not. That's okay. But make sure we understand what we did wrong. A lot of us made it this far, and then we wanted to take this little 2 right here and multiply it by all of these things. Unfortunately, you can't do that. That is an exponent, okay? So I'm sorry, but we talked about that. We cannot distribute exponents. We have to understand why they're there, right? And it is there to tell us that there are two 2x plus 1s that are being multiplied by each other. So what this problem actually is something that looks like this. Okay? When I have parentheses together like that, it tells me I have to distribute 2x times 2x is going to be a 4x squared. 2x times 1 is a plus 2x. 1 times 2x is a plus 2x. And 1 times 1 is plus 1. We still have a negative out front, and we still have a plus 3 at the end. Now I'm just going to distribute out this negative. I can go ahead and combine this 4x first, though. If I didn't do that, it's okay. I'd still get the same answer if I distribute out the negative first. So negative times 4x squared is going to be negative 4x squared. Negative times 4x is negative 4x. Negative times 1 is negative 1. And add 3. And then my last step is combine like terms. And I know negative 1 plus 3 is 2. So that would be my final answer on that one. Okay? A lot of steps, but that foiling that part out, that is an Algebra 1 step, okay? And I know that unfortunately we are the group that were quarantined during Algebra 1, just like Miss Browning is right now. I know how bad it sucks, but that is what that intervention time is for. So if you are needing some intervention on some Algebra 1 concepts, make sure whenever I get back that you come see me during one time and we can do some work on how to do those kind of problems, okay? This is not going away. This is still going to be a part of our units moving forward, so we need to make sure we have that concept mastered. Okay, I'm going to do a little cleaning up just because this is a lot right now. So I'm going to erase just so I can see these next two problems. Next one is simplify f of x plus h of x in graph. A lot of us did get this one right, but some of us didn't know how to substitute those in. But we did talk about this, so if we were just substituting in, all we're doing is just pulling in the letters it tells us to, putting them into that problem, simplifying it, and then graphing it. It should be a y equals mx plus b problem when you get done for this graph. So 2 times f of x is just going to be 2 times 2x plus 1, plus h of x is going to be plus 1/2 x plus 6. If you notice, I did put that into parentheses, because sometimes this h of x function, I think maybe on the quiz or hint, this was a subtraction sign. Make sure you include parentheses here because that whole thing would be being subtracted. Okay, just like the whole thing is being added, if it's being subtracted right there, you need to make sure you have these parentheses so you know to distribute out that negative sign to both of those things. Okay, but this one is addition, so I don't have to worry about that. So first thing I want to just distribute out, I get 4x plus 2 plus distribute out a 1, so I can just leave this the same. And now to simplify. 4x plus half x, well I know that 4x is the same thing as just 8 over 2x, if I make common denominators here. So 8 halves plus 1/2 is 9 halves x. 2 plus 6 is just a plus 8. So this would be my answer on that one. And then I would just want to graph it. It's okay if you left that as 4.5x too, that's the same thing. If I were to graph it, I'd go up 8, put a point, and then I'd go up 9 over 2, or I could just drop down 9 and go left 2, and I would have a line that looked like that. Not super pretty, okay, but you get the gist of it. Let me know if you have questions on that. Again, guys, I am reachable through Canvas anytime during this quarantine, so if you have a question, something's still just not clicking, make sure you let me know. And then the last one, for some reason, we did a warm-up just like this, but it said find the inverse of f. It used the word inverse, but for some reason, whenever I put this notation, h to the negative first of x, we forgot what it meant. This just means inverse, okay? A lot of us did this. We knew that we were using h, so we took this half x plus 6, and then we took it to the negative first power. I'm not quite sure where that came from, okay? I think we just got a little confused, but make sure that you know that this just means find that inverse of h of x. So our first step on finding an inverse is just to change the h of x into y equals. Okay, then we want to flip-flop our x and y to keep everything else the same. And now we just solve for y. So first step is just to subtract this 6 over. I get x minus 6 equals half y. Okay, now we get to this point. A lot of us knew to divide by 1/2, but we totally forgot how to divide fractions, okay? So we could divide by 1/2, that's totally fine. If we do x divided by 1/2, this is the same thing as 1x. 1 divided by 1/2 is not half x, okay? It is not. If you type in 1 divided by 1/2 in a calculator, you will not get 1/2 x. Instead, you will get 2x, okay? And negative 6 divided by 1/2 is not negative 3, okay? Make sure you type that in your calculator. A better way to do this, though, would be instead of dividing by that 1/2, just realize, hey, to get rid of 1/2, I can multiply by 2 on both sides. And when I do that, this 1/2 and this 2 just cancel, and this 2 just distributes out. And that's a lot easier than worrying about fractions. Last step is just to change that y into we were using h. Change that y into h to the negative first of x equals that 2x minus 12. Okay, so that, again, is the fraternal twin to our quiz, so make sure you understand those problems and you're ready for whenever I get back on Tuesday to do that retake. Now I want you to get out those notes packets that I handed out this week, the newer notes packets. If you don't have one, there are some right over on the shelves underneath or by the window, but they say 1.3. Don't pick up the 1.4 or the 1.5 packets yet because we're not ready for those. But go ahead and grab that, get situated here, and let's go ahead and get going. Okay, so I think you should have these filled in already, but if you don't, we'll just real quick go over these steps one more time. Isolate the absolute value bar, get it by itself. Make a decision, is it an and or an or? If it's a greater than sign, it's going to be an or. If it's a less than sign, it's going to be an and. Then we're going to split it into 2 problems. The first split, you just drop the bars and keep it the exact same. Second split, drop the bars, flip the sign, and make the right side negative. Then you solve it, graph it, and then check for those extraneous solutions, and we'll go over what that means again, because I think there was some confusion in a couple of class periods, but we'll make sure that we're all on the same page on that. Okay, first one. Whether you have done this one or not, just go ahead and follow along. First step, is it isolated? Yes, it is. It's all on the left side, okay? Nothing else is on that left side besides that absolute value. So I'm going to split into 2 problems. The first one, I keep everything the same, just drop the bars. the next one, keep the left side the same, change the sign, make it negative. And then we just solve these like normal. Subtract 3 on both sides, on both. Okay, going back to where we isolated, this was a less than sign, which tells me that this is going to be an and problem, which means I really hope that it turns out looking like a line segment, or I might have quite possibly done something wrong. When I put these on a number line, -12 is less than 6. I'm just going to put the two numbers. You can have other intervals in there as well, but just as long as you have those two numbers on the line, it should be fine. Open or close dot, we know that these are both not equal to signs, so they are just going to be open dots. And then for less than 6 and greater than 12, I know that 6 would be shading this direction, greater than -12 would be shading this direction, and these do form a line segment, which is good, and that's what I wanted. Then we have our last step, which is checking the extraneous solutions. What that means, I need to check something in every segment of my graph, okay, even the segments that are undefined. So I need to plug in a number that is less than -12 first. So think of an easy number, something that's going to be easy for me to just plug right in to this problem where we split off. So what I'm going to do is I'm going to pick -20. That's pretty simple. And I'm just going to go and plug -20 in for x. So -20 plus 3 less than 9. What is -20 plus 3? -17. And the absolute value of -17 is 17. Is 17 less than 9? No, not on any day of the week, right? It's definitely not. So, since I don't have any graph drawn in that section, that means I did it right. I wanted that to be undefined, and it was. So that's good. Now I'm going to do this exact same thing, but I got to plug in something in the middle section that is defined. So I need a number that's between 12 and 6 here. Let's pick something easy. Let's just do 0. So 0 plus 3, what is that? Obviously 3. Absolute value of 3 is 3. Is 3 less than 9? Yes. Okay, well I had shading there, so that's good. That means it's defined. Did it right. Awesome. Okay, last segment is just this part on the right. I can do anything bigger than 6. Let's just do 10. So we'll plug in 10 for x plus 3 is 13. Is 13 less than 9? Nope. So that's not defined. Don't have a drawing, or don't have solutions over there, so I'm good. Alright, interval notation on this. Reading from left to right, we start at -12, open parenthesis, and we end at 6. Again, open parentheses because these are open dots. Okay, let me know if you've got questions on that. Moving right along. Okay, don't worry about problem 9 right now. We're going to skip down to number 10. So again, we treat these just as if they were variables until we get them isolated, okay? So if this was 2 minus 3x was greater than 11, then we would just subtract the 2, divide by -3, which is exactly what we're going to do. So don't overthink these, okay? So subtract the 2 here. We end up with -3, x plus 9 is greater than 9, divide by -3. And our new problem is going to just become x plus 9, absolute value, is less than, because we divided by a -3. Okay, so now I'm able to split this problem. Keep it the same for the first one, flip and change the sign for the second. Now I'm just going to subtract 9 on both sides. X is less than -12. Subtract 9. X is greater than -6. Okay, looking at where I originally split, this was a less than problem, so I want this one to look like an and. Okay, so let's see if it does. Starting off, -12 comes before -6. I got open dots. Less than -12 means I'm going left. Ooh. Greater than -6 means I'm going right. Okay, so this looks like an or problem, right? So my first instinct is that this is no solution, but let's go ahead and check our extraneous solutions and just make sure. So if I'm checking something in this first section that is defined, but I need a number less than negative 12, we'll just do negative 20. This becomes negative 11 absolute value, so just 11, which is less than or equal to negative 3. Is that true? No, that's not true. So this area is actually not defined. Now let's try something in between negative 12 and negative 6. Okay, let's just do negative 10, that would be easy. Negative 10 plus 9 is just going to be a negative 1. Absolute value of 1 is 1. Is 1 less than negative 3? No, so this region's also not defined. Now we've got to try something on the right, something bigger than negative 6. Let's just do 0. 0 plus 9 is going to be 9. Absolute value of 9 is 9. Is that less than or equal to negative 3? No, it is not. So this is not defined anywhere, okay? It is going to be a no solution. It is really good that I checked my extraneous solutions on this one, because if I wouldn't have done that, I would have left it as an OR problem, okay? Which wouldn't have been right. I'm going to tell you right now, most of the time, especially on your test, we're not going to try to trick you on there, okay? So it'd be good to show that you know how to plug in the extraneous solutions, okay? Most of the time it's going to work out, okay? So don't get frustrated if this is a big concept and it's confusing you as far as just the plugging in the solutions at the end. I'm really just worried about, can you graph this? Can you get it to this point and put those on a number line, okay? As far as the extraneous solution thing, you might see that on the EOC, you might not. I don't know, I've never seen the test, okay? But know how to do it. Don't freak out if it's a little bit confusing. If you've got questions, make sure you message me on Canvas or ask me next week when I'm back. I might try to set up a Zoom session as well tomorrow with you guys, just so that we can do a little Q&A. I guess not tomorrow, but you guys will have class on Friday, so we will be diving into 1.4, but there will be a video, there will be an activity for that, so don't worry about that. But we're going to make the best of this. I know it's a sucky situation, but just let me know if you have questions. Your homework is to complete the 1.3 homework problems in the packet, and then obviously do that 1.3 homework check. I will be grading those from home, so I'll try to get you some immediate feedback whenever you do fill those in. And then as far as everything else goes, if you check your grade on SIS and you would like to do a retake, you need to do the following. Go on Delta Math, and there is a set of problems. There's like 15 problems, and it is called the Quiz 1.1, 1.2 retake. You cannot take a retake until you get that completed. So that is going to be the first question that I ask you when you come to me on Tuesday and say, hey, Miss Browning, I'm ready for my retake. If you don't have that Delta Math done, you're not getting it, okay? It's a little bit of a review of foiling. It's a little bit of a review of dividing by fractions, okay? It's not the exact problems from the quiz by any means. It's some of those preliminary concepts that we struggled with on our quizzes, okay? So do that. If you're wanting a retake, you've basically got until Tuesday to do that. So work on that and let me know if you have questions, guys. I appreciate your time. Please be nice and respectful to the sub, and I will see you when I get back on Tuesday, and I will probably see you on Zoom on Friday. So thank you, and I will talk to you later. We're going to skip this problem for now. So again, talk to you guys later. Bye.